I am Anil Kumar. Welcome to my series on combinatorics. We have discussed about the basic counting principles, permutation combination, and now we are discussing examples on probability. I have taken a very important test example which is based on probability of finding some cases in poker hands. Now, poker is a game of cards in which five cards are distributed from a deck of 52 cards, a standard deck of 52 cards. We'll take actually 12 questions in this particular video discussing all possible possibilities which I have seen so far in previous test papers on this particular topic. So that is going to really help you a lot. You can learn more from me and discuss the strategy by writing to me on the given email. Well, as you know, the poker hand is five cards in your hand when you randomly pick five cards from a deck of 52. Now, in this deck of 52, some students may not know clearly, we do have 13 kinds of cards: Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, and King. As shown here, we have shown a hand which has 13 cards, all of diamonds, right? So, well, that is not a poker hand, but these are the 13 cards of one particular suit, which is diamonds. We have actually four suits: spades, hearts, diamonds, and clubs. So 13 times 4 is 52. Hearts and diamonds are red in color, so 26 red cards and 26 black cards, which represent the spades and club suits, 13 of each. Now, when we are distributing 5 cards out of 52, then in a sample space, because we're talking about probability, so the denominator will be total number of ways of selecting 5 cards randomly from a deck of 52. So that gives us a choice of 52 choose 5. Now 52 choose 5 is 52 factorial divided by 52 minus 5 factorial times 5 factorial. And that value is 2598960. So that is going to be the denominator in all the cases. So I've just given this right on the top. So most of the examples, we see a probability of doing that, but also the numerator part is also the number of ways or the arrangements or the choices in which you can get that particular combination perfect. So this question could also help students who are still working on combinations. Now, it is really a case of combination because we are selecting five cards and five cards in our hand. It doesn't matter in which order they have come, right? And therefore, it is a case of combination. And in all the solutions, what you will see is N choose R. Perfect. Now, with that, let's move forward. So when we say that the number of outcomes to draw 5 cards from 52 is 52 choose 5 and we get a value, that also indicate to you that these are also the number of hands for one person with 5 cards, right? So sometimes the question could be how to find the number of hands when 5 cards are chosen from a deck of 52. As far as the question goes, at the very beginning, I should tell you, without giving you a long lecture, that what are we going to discuss? These are the different kinds of combination of 5 cards in the poker game, and we are looking into their probabilities, right? We could get a hand where we are interested in finding number of ways or the probability of getting, let us say, a straight, a flush, a double or a triple or a full hand. So all those combinations will be considered in this particular video. So let's begin with having a picture of questions which we are going to discuss. So we'll find the probability for following hands in the game of poker. So single pair, two pairs, a triple, full house, that means a triple and a pair, Four of a kind, flush. When we say flush, it means five of the same suit. Now, here we have some variations. When we have five of the same suit, we are excluding the ones which form the straights, right? So, royal flush is the one where you get 10 jack, queen, king, and ace of one color, right? That's a royal flush. We have a straight flush and straight normal flush. And then we'll talk about none of the above. That is very tricky. So, getting a normal hand, which is 50% probable, you don't get any of those options normally in the game. So, that is the none of the above case. We'll also look into specific cases of finding a probability of getting one spade card and four diamonds card, or we'll take up a case where we'll look into at least one card from each suit, right? So these are the 12 questions which we are going to discuss. Let's begin with the very first one, which is to find the probability of single pair in the game of poker in which cards are randomly drawn from a fair deck of 52 cards. Now, each card is distinct. There are 52 distinct cards, right, which we are talking about, and four suits, 13 of each kind. Now, when we say each kind, we mean ace, which represents one also, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the 10, and then jack, queen, and king. So there are 13 cards, right? Now, we need to figure out the probability of getting a single pair. What does it really mean? It really means that we have to fill in these five spaces, and in one of these five spaces, we have a single pair. So double we are calling. So we're just saying D and D. Now that is the restriction for us. So let's think about how do we get two of the same kind? That is what we have to look into. Perfect. So what I've done here is written a neat format, and this format should help you to understand all the following examples and also easily get solution to similar questions, right? So first thing is we have to choose the kind of the card, right? So it could be like as shown here, two eights, let us say, right? So we have to choose a kind. So one of the 13 is what we have to choose. So 13C1 is what we have chosen. So one of those 13 in this case shown in the figure is two eights. Well, so that is 13 out of 1. It could be any of those 13 numbers. So 13 choose 1 is 13, correct? So this, you understand 13 choose 1 is actually the number 13 itself. So if we have a choice of choosing from the 13s, right? Now if you choose one, for example here, we have taken 8. In that case, you have to pick up 2 of those 8s out of 4 available. So we have 4 of that kind, one of hearts, one of spades, one of diamonds, and one of clubs. So 4 choose 2 gives you can choose any 2 of those 4 because you just need a double, right? Okay, so that gives you another factor which is 4 choose 2. Now, we are left with the positions 3, 4, and 5. Now, in the positions 3, 4, and 5, you cannot choose the number or the kind which you have already taken. So, in that case, you are left with 12 only. Now, from those 12, you have to choose 3, right? You cannot choose from the number or the kind which you have already taken, right? So from those 12, you have to choose 3, but only one of each kind. You understand? So 12C3 tells you that you choose 3 other numbers apart from 8. In this case, it is king, 9, and ace as shown in the figure. Perfect. Now, these you have to choose different numbers, and therefore we have only of one kind, 4C1. There are 4 of each kind. If you pick up 2, then we have 2 doubles. It violates our assumption here. That is, we are working only for one double, correct? So you have to choose only of one kind from those 3 which you have taken. So 4C1, 4C1, 4C1 for all the 3 gives you this factor, which is 4 choose 1 cube. So when you multiply all three of them, that that gives you the possible sample solution, right? The answer, the NA value, right? So when you're talking about probability, in probability for any particular condition, here we are using a double. In that case, we have to see how much are favorable cases and what is the sample space. So sample space in all our examples will be 52 choose 5, and in this particular case the product of all this will be the favorable cases. So calculating that, we get our answer, which is this number 0.422569. You can multiply them all, divide by 52 choose 5 to get the probability, right? So around 42% is the probability of getting a double in case of a game of poker. Is that clear to you? We're going to adopt a similar method to answer rest of the questions. So example number 2 here is two pairs, right? So out of 4, we have two pairs. Fifth is a different card. Now, what are you going to do? Well, again, we have to choose two of a kind, right? Two different numbers. From 13, it could be any two, right? So that means we again have these five spaces to fill. Now, here we are saying two similar, right? So these and then another. So there are two pairs, two double pairs. That is what we're trying to figure out. Probability of getting a hand which has a double pair. So the question for you here is probability of double pair in the game of poker in which cards are randomly drawn from a fair deck of 52. So basically, you have to choose 2 from those 13. So 13 choose 2 is your first factor. Perfect. Once you do that, then what is, we have to choose 2 of each kind, and each kind is 4, right? So 4 choose 2 gives you whether you're picking up spades, hearts, diamonds, or clubs, right? So 4 choose 2. So we are done with these 4 cards. Now let's look into the fifth card. Now in the fifth card, it should not be those which you have already taken. So from 13, 2 are out. We are left with 11, and you have to choose only one. Now you have 4 choices of choosing that one. And so times 4 choose 1. That becomes a numerator. In this case, we know what the denominator is. 52 choose 5. And so when you work it out, you get around 0.0475, which is just 4.7%. You see? So we had around 40% to get one pair, but just 4.7% to get two pairs, right? Okay, so here we have shown two pairs, queens and sevens, right? Now let's move on and take the next example. So next example is to get a triple, right? To get a triple, three of one kind and some other two cards, right? So again, what is the strategy? Well, from the 13 cards, you have to choose one kind for which you have to pick up 3. So 4C3, right? So 13C1, 4C3 gives you the first factor of the triple. The other two cards have to be different. So from 12 remaining, you have to choose 2 and one of each kind. So 4C1, 4C1, which gives you 4C1 square. I hope you're getting the idea of how to get this numerator, which is the favorable cases in our case for finding the probability. Total number of options remain the same. You're choosing 5 out of 52. So when you work this out, you get 0.021128, which is almost 2.1%, right? It is further reduced. Now, let's look into the fourth example where we're talking about full house. When I say full house, it means a triple and a double, all 5 in kind of pairs, right? So triple and a double. How are you going to solve it? I'd like you to pause the video now since you understand the strategy. We have to choose out of 13 two numbers, right? Two of kinds. So 13, choose 2 should be our first thing, right? So, and then one of them is going to be 3. So this will be 13 choose 2. Let me correct this. 13 choose 2. So 13 choose 2. Correct. So we are choosing two items here. Now, in that case, okay, we'll go with one and we'll do the way it has been. So in this case, let us choose one of them first. And so we have 13 choose one. So we have chosen the one which we want to be a triple, for example. So let's go with this. 13 choose one. And once we choose that, out of the four available of that kind, we have to take three. So 4 choose 3, right? So we got 13 choose 1 times 4 choose 3. Now, from 13 kinds, we have already taken one. We're left with 12. So let's choose one of those 12s and two of them. So 4 choose 2 gives us the other factor to be multiplied, and that is our favorable cases, right? So everywhere, what we are writing here to find the probability is the probability or whatever we're trying to figure out is ratio of favorable cases to the sample space. The sample space, to remind you, is 52 choose 5. And in this case, the favorable cases are 13 choose 1 times 4 choose 3. That is for the triple times 12 choose 1, 4 choose 2. That is for the double. And when you calculate this, you get 0.001441. So even lesser probability, right? So that is how we see that the probability really decreases. So the chances of winning with that card are pretty high, right? Now, example 5 here is we need to have four of a kind. So I've written F, F, F four times, and the fifth card is different. So again, we have to choose one kind, which is 13 choose one, and 4 out of 4. There are those possibilities. So that gives you the first term of F, F, and F, four of one kind. Now the fifth one has to be from the remaining 12. 12 choose 1, and we have to pick up only one card, so 4 choose 1, correct? So that is how we are going to get the next factor. That becomes now the numerator, the favorable cases, 13 choose 1 times 4 choose 4 times 12 choose 1 times 4 choose 1, divided by the total number in our case of selections, which is 15 choose 5. And this gives you an answer, which is 0.000240. Now let's take up the next example, which is called the royal flush. Well, what is a royal flush? Well, we have only four royal flush. It is ace, king, queen, jack, and 10. So these are the five cards which we treat as a royal flush, and they could be of spades, right? So they could be of spades, they could be of hearts, and they could be of diamonds, or they could be of clubs. So they could be of any one of these four kinds. And therefore, we have only four options for this royal flush. So we have 4 in the numerator divided by the choices, which are 52 choose 5. So this is called the royal flush, right? Next, so it is a straight with the highest straight which you can get in the same color. So it is called the royal flush. So whenever we use the word flush, it means all of the same kind, right? Suit has to be same. Now, example number 7 here is a straight flush. Straight flush really means that like ace 2 3 2 3 4 4 5 6 6 7 8 9 10, like this, right? The runners, the sequence elements, right? So where the numbers are running are consecutive numbers. So those kinds are straight flush. Now when we're talking about straight flush, we'll kind of exclude the royal flush from it, since that's a higher card. So why to mix it up? So now the question is, what is the probability of getting five cards of the same of a suit forming straight, excluding royal flush, in the game of poker in which five cards are randomly drawn from a fair deck of 52 cards? So we'll actually exclude those four cases from these. Well, how do we get a straight flush? So straight flush also means same color, right? Same, I should say, suit, right? So we have four suits, correct? As you know, we have four different suits, but how do you get flush? So we could get as one, two, three, four, five, because we have a set of five cards. We could have two, three, four, five, six. Likewise, the last combination starts with 10, Jack, Queen, King, and Ace, right? So those are the ones. So you can clearly see that we have 1, 2, up to 10, right? So we have up to 10. So that is what we have. And since we have four suits, so we have 4 times 10 total combinations. The royal flush, four of them will deduct them, correct? So we have 4 times 10 minus 4. Now this minus 4 is because of the royal flush being excluded. So total straight flush without the royal flush will be 4 times 10 minus 4. Perfect. So that is how we get the numerator possible cases. Divide by 15, choose 5, and that gives you a very small probability. 0.0000138517 when you calculate this particular number. So I hope that is absolutely correct. So basically you understand how do we get a straight. So in a particular suit, you can always get 10 straights. Do you see that? Since we have four suits, we get 40 straights. Out of these 40, four are the royal straights and we remove them. So we got 36 of them. So this type, we have 36 divided by 50 to choose 5 to get the probability. So I hope that is absolutely clear. Now let's move on and take the next example where we talk about a flush without straight, right? That flush means all of the same suit. So now the restriction is to choose one of the four suits. Since there are four, so 4 choose 1 gives us that number. Now once you have chosen that, since every number has to be taken from that particular suit, since shown here is diamonds, so we picked up all diamond cards. That really means you have to choose 5 out of those 13 cards of diamonds, correct? So 13 choose 5 is what gives you those particular flush cards, same kind in the hand of 5. Is that clear to you, right? Now, in this particular case, we have to remove the straights, correct? So it is kind of important to understand that how many straights do we have? We are only interested in the random cards, not organized as pairs or organized in some other ways, correct? So we have to remove those which are consecutive, which are coming together, correct? The straights. So you cannot have pairs in the same color, of course, but you could have the running or the sequences. As you know, there are 40 of these, right? So 36 plus 4 makes it 40. Taking away 40 from our flush, all kinds, will give us the numerator favorable cases for this particular case where we are looking into the probability of getting all the 5 cards from the same suit, right? And we are excluding these straights in that because the straights with the same flush or the color is a much higher ranking. Perfect. So we get our answer in this case at 0.0019654. So I hope that is clear. Now let's take the next example where we're talking about a straight. Now when we say a straight in this case, we'll exclude those which are including the same color or which are the royal flush, correct? So we'll include those ones. So the question here is probability of getting a 5 cards in a sequence excluding straight flush, correct? So we'll exclude all those. So that means, as I was saying, we could have a set of 5 in consecutive running numbers like 1, 2, 3, 4, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, and so on. The last one starts with 10. So clearly you can see that first starts with 1, then the 10th is the last one. So we have 10 of these kinds clearly, right? Now, since we have 4 suits, 40 in all, correct? That is what the concept is. So we can see that there are 10 straights, correct? And each kind has a card of from four suits, correct? Because it could have been every card there in between in these 10 straights could be from one of the four suits. It could be from spades, hearts, diamonds, or clubs, right? So that makes it 40 into 4, choose 1 to the power of 5. So every space here, 1, 2, 3, 4, 5, we know we are having 10 of these, but at every place we have a choice of choosing any 4 of them. Do you see that? 4 of a different suit, because these traits are not of the same color, right? Not of the same suit. They are not flush straights. But in general, so in general, the choice is 4. That gives you 4 to the power of 5 right there. So 10 times 4 to the power of 5 gives you all possible straights. All possible straights, correct? Now from that, we are excluding the ones which are of the same, I should say, flush, right? So 40 of those which we figured out, right? So taking that away gives us the straights which do not include the straight flush, correct? So that gives you the probability of 0.00392465. Now, we are almost at the end, 3 more questions to go. Now we have to figure out what is the probability of getting none of these complicated ones which we figured out, right? Now that is actually more complicated. So now we look into the probability of not getting a double, not a triple, not four, not straight, not flush, none of these. A simple 5 cards where all are of different kinds, right? All are of different kinds and also of different suits, right? So that is kind of thing which we're now looking into. Okay. So basically, we are choosing 5 out of 13. So that gives us a whole lot of choices. 5 out of 13 actually has everything in it, right? But what we need to exclude from here, we need to exclude all these straights and the flushes, correct? Both the things we need to exclude. Okay, so first, all these straights. So excluding straights means there are, for every set, there will be 10 straights, correct? If you take any particular sequence, in that case, there are 10 possible straights. So 13 choose 5 minus 10. So these are the probable set. Now, we have to choose 5 of each place, correct? So in that case, 4C1, every place you have to choose a card, right? 4 choices are there at each spot. But these 4 choices, we cannot take the same color, right? So we'll avoid the flush. So this 4 comes from the flush, which we need to subtract from the choices which we make for the suits, right? So when you do that, you multiply it with 15 or with 13 choose 5 minus 10 to get our probable cases. So the numerator here is 13 choose 5 minus 10. So that these are all the numbers which we get for random 5 cards not organized at all in any way, as we had selected earlier before this, right? Now, from there, we could have each of different color. So which is 4 choose 1 and to the power of 5, since 5 spaces are being placed. But it is possible that out of these, there will always be 4 which will be of the same suit. So that is what we call flush, right? So we have to avoid those. So minus 4, and that becomes the numerator, and the denominator, is 52 choose 5, and that gives you the probability of none of the above, right? Do you see that? So that is what the answer is, which is almost 50%. So 50% chances of not having one of those is very clear now. Is that clear? Now so the game of poker has these 5 cards, and so these are very famous questions which are always seen in test papers. I hope this knowledge is going to help you in answer those questions correctly. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.